Okay, we're going to be studying similar figures. Now, all these figures that you see here on this screen all look similar, and probably they are similar, but the thing is you don't know that. In mathematics, you don't know that until you have certain conditions that are met. So let's study what similar figures are. Okay, first of all, if two figures are similar, and I'm telling you that these two are similar, then this is the way that you write it. Triangle ABC is similar to triangle DEF. So this symbol, like this, means is similar to. Just the same way this means equal, this means not equal, this means greater than or equal to. This means is similar to. Okay? Alright, now let's look at this. Okay, a polygon is a closed plane figure formed by three or more line segments that do not cross. Okay? 1, 2, 3. Is that a polygon? No, that's not a polygon because it's not closed. Now it's a polygon. Okay? A triangle is a polygon. Rectangle, a square, a rhombus, a pentagon. All these are polygons except for one of them. Which one of them is not a polygon? Correct, it's this one. This one is not a polygon because the lines cross each other, okay? So, the lines cannot cross each other in order for it to be a polygon. So, two polygons are similar if the corresponding angles have the same measure and the lengths of the corresponding sides form equivalent ratios. So, let's go back over here. Oh, one more page. The corresponding angles, 48 matches to 48, 44 matches to 44, 88 matches to 88. Corresponding angles are equal or congruent. And the sides have to be proportional. So 9 times 2 is 18. 8 times 2 is 16. 6 times 2 is 12. So these are proportional. You just got to multiply them all by 2 to get the big triangle. So let's go back to the definition. Two polygons are similar if corresponding angles have the same measure and lengths of the corresponding sides form equivalent ratios. Alright, now how do you write corresponding parts? If you're going to have to determine if corresponding parts are equal or form the same ratio, then you got to be able to identify corresponding parts. So rectangle Brad is similar to rectangle Rick in much the same way that Brad Pitt is similar to Rick Falk, of course. Name the corresponding parts. Well, let's look. We've got BR is similar, BR corresponds with RI, BR and RI, and this is the way you indicate a segment. And then we've got RD and we've got IK. RD and IK, and then we've got DA and KC, DA and KC, and finally we've got AB and CR, AB and CR. Now don't forget, you also got corresponding angles, so make sure that you do not forget to do corresponding angles. So angle B, that's how you write angle B, corresponds to angle R. Angle R here corresponds to angle I. Angle D, angle D corresponds to angle K. And finally, angle A corresponds to angle C. So, in a rectangle, there are two rectangles, there are 8 corresponding parts. What about if you had two triangles and they were similar? How many corresponding parts would they have? 6, yes, because there would be 3 angles and 3 sides. Okay. Are these two rectangles similar? Remember, they have to have corresponding angles have to be congruent or equal, okay? So let's check to see if that's true. Right angle, 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 right angle. All the angles are equal. So that part of it is satisfied. Then the corresponding sides have to form equivalent ratios. So we go 5 corresponds to 3. 5 over 3 is equal to 4 over 2. And then we check. 3 times 4 is 12. 5 times 2 is 10. That is not true. So these are not similar. Okay. Now, let's find the missing measure. That's what math, that's what algebra is all about, is finding that x, isn't it? So we got triangle ACT, and we got triangle ODG, and they're similar. Find the value of x. Let me move this down so you can see the whole thing. Okay, did you see the really humorous little thing that I did right there? It was ACT and ODG, but really it's CAT and DOG, cat and dog. Okay, so anyway, enough with the extraordinary great humor. We've got x right here. And what does that correspond to? X corresponds to 50. And then we've got to find something else that corresponds. We've got 32. And we've got 40. So now 50 times 32 gives us 1600. X times 40 gives us 40x. Divide by 40 on both sides. And that gives us x equals 40. So x is equal to 40. And that's how you find the missing side. Alright. ABC and PQR are similar. Find the length of segment AB. So this is what we're going to try to find right here. So if it's what we're trying to find, it is x. So let's see now. We've got x in our triangle that we're starting with. And what does it correspond to? The 8. And then we've got over here, we've got 21. And what does it correspond to? 14. Now, a question before we move on. Why didn't I choose the 16.8? Well, the 16.8 corresponds to this side, and I'm not given a measure right here. So since I'm not given a measure, I can't use the 16.8. Now let's go back to our problem. 8 times 21, 168. X times 14, 14x. Divide both sides by 14. And we get 12 is equal to x. Alright, it's your turn now. Alright. Find the length of segment RP. Pause the video. It's your turn now. Okay, so we've got RP is what we're looking for. This is the segment that we're looking for right here. So that's going to be x. So we put x over. What does it correspond to? Well, it corresponds to the 16.8. Whoops, 16.8. And then let's see, if I use the 8, there's nothing there for me to compare it to. So I've got to go 14 and 21. So I go 14 times 16.8. I don't think I remember what that is. So we go 168 times 14. And that gives us 672 and 168. That's 2 and 15 and 12, 13 and 2. So that gives us 2352 with 1 decimal place equals 21x. Okay? And then we work that out and we divide by 21 on both sides. And that gives us 11.2 equals x. Triangle ABC and triangle PQR are similar. Find the measure of angle A. Do you remember? Right. The angles have to be exactly the same measures, okay? If it tells you that they're similar, so these angles are going to be the same. So that means that if we're trying to find this one, it corresponds to angle P. So if A corresponds to P, that means that A has to be 92 degrees. Your turn. One thing you're going to have to remember now in this one is that all triangles have 180 degrees. That's a clue for you. So find the measure of angle Q here. All right. So go for it. Pause the video and see what you get at. All right. So if this one is 92 degrees, well, excuse me. This is what we're looking for. In order to get this one, we've got to know the other two, because this one is 53. B corresponds to R. So that means this is 53. If we know these two, what can we do to get this one? Remember, I told you that the whole thing is equal to 180 degrees. So we go 180. What do? Yes, we subtract 92 and we subtract 53. And that leaves us with the one angle that we don't have, which is 45 degrees. If you got that, you did a really good job.